Hello and welcome to the concluding lecture on differential equation. Today we shall be starting with linear differential equations of first order. Later we are going to find the solution to them, and finally we shall conclude by dealing up with the problem that would be based on linear differential equation solution. Beginning with the linear differential equation of first order, a differential equation of the form dy by dx plus py equal to q, where p and q are functions of x only, is called a linear differential equation of the first order in y. In this linear differential equation, if q is equal to 0, then the equation is said to be homogeneous linear differential equation. Otherwise, it is called non-homogeneous linear differential equation. Likewise, a differential equation of the form dx by dy plus px equal to q, where p and q are function of y only, is called a linear differential equation of the first order in x. Next, we are going to find how to find the solution to a linear differential equation of the type dy by dx plus py equal to q, where p and q are function of x only. Then it has its integrating factor as e to power integral of p dx, and its solution is given as y into integrating factor, which is e power p dx, equal to integral of q into integrating factor, which is e integral of p dx plus integration constant c. Now if the equation is of the form dx by dy plus px equal to q, where p and q are functions of y only, then its integrating factor is given as e to the power integral of p dy, and its solution is given as x into integrating factor, which is equal to q into integral factor and its integral with respect to y plus integration constant c. Another condition that exists in this, if q is equal to 0 in the above differential equations, then the solution is given as y into integrating factor, that is e to power p dx equal to c for the equation of the type dy by dx plus py equal to q, and the solution for dx by dy plus px equal to 0, the solution is x into e to power p dy equal to c, which is a constant. Thus, using these solutions, we can find the solution to a linear differential equation of the first order in x or y. Now we are going to find the solution to a linear differential equation of first order in x or y. Now here we are required to solve the given equation, which is of the form dy by dx plus 2x divided by 1 plus x square y is equal to 1 divided by 1 plus x square to whole power 2. Now here we have an equation of linear form in y, in which we have dy by dx plus py equal to q, where p is 2x divided by 1 plus x square and q is given as 1 divided by 1 plus x squared to whole power 2. Therefore, we might write this equation in the form dy by dx plus py equal to q. Now, in order to solve this equation, first thing to be done is to find the integrating factor. Now, in order to find the integrating factor, what we need to do is we need to find the integral of p dx, which is equal to e power integral of p, which is p is 2x upon 1 plus x square dx. This gives us the value of integrating factor as e to power log 1 plus x square, and thus the value is 1 plus x square of the integrating factor. Now the solution to this differential equation is written as y into integrating factor, which is equal to integral of q into integrating factor, and this is integrated with respect to x plus c, where c is a constant of integration. Thus, replacing integrating factor by the obtained value, we have y into 1 plus x square is equal to integration of q, which is 1 divided by 1 plus x square to whole power 2 into integrating factor 1 plus x square dx plus c. This gives us the equation y1 plus x square is equal to integration of 1 divided by 1 plus x square dx plus c. Thus we may rewrite it as by integrating y1 plus x square is equal to tan inverse x plus c, where c is an arbitrary constant. Thus in this way we have solved the given linear equation in y, which was of first order, by finding out the value of the integrating factor and then finding the solution to this differential equation by the use of this integrating factor. Next we have another problem which has y plus 3x squared dy by dx equal to x. Now this equation has been labeled as, let's say, equation number 1. Now this equation can be rewritten in the form x dy by dx is equal to y plus 3x square, or we may write it as dy by dx is equal to y by x plus 3x, or we may rewrite it as dy by dx minus 1 by x into y is equal to 3x. Now this is a linear differential equation in y, where integrating factor is equal to e to power integral of p dx, where p is minus 1 by x. This gives us a value of integrating factor as e to power minus log x. This is equal to 1 by x. Now we have this integrating factor. Now in order to find the solution, we have the solution as y into integrating factor, which is equal to integral of q into integrating factor plus c. Now here q is equal to 3x. Therefore the solution can be written as y into integrating factor, which is 1 by x, is equal to integral of 3x into integrating factor 1 by x dx plus c. This gives us equation y equal to 3x square plus cx, where c is an arbitrary constant. Thus to the given differential equation we have found the solution, which is given as y equal to 3x square plus cx. With this we conclude the last lecture on differential equations, which was based on linear differential equations and their solutions.